Our next discussion is on deploying IP subnets. What does that mean? It means we're going to talk about how we actually deploy them and some of the most common ways of deploying our IP subnets to get ourselves ready for the certification exam. So the first discussion here to warm us up is to remind ourselves about point-to-point connections. So in this particular example, we have a point-to-point connection between where? Between, let's say, a office in one location and an office in another location. So how many IP addresses do we need for a point-to-point connection? We only need 2 addresses. We need one address here. We need one address here. And if you think back to the chart that we had a little bit earlier, and that's why knowing this chart for the certification exam is going to be beneficial for you. If we only need 2 addresses, then /30 is the way to go. It gives us 2 addresses. Why does it give us 2 addresses? Well, I can show you the math right now. You got 2 bits left over. So if you got 2 bits left over, that's 2 to the power of 2 minus 2, which equals 4 minus 2, which equals 2. 2 addresses. So you get 4 total addresses, right? 4 TOTA total addresses. And then you got a minus 2, leaving you with 2 left over. So /30. And that's why you have /30 in that diagram. All right. So now what I want you to realize is that there is /31 that you can use, okay? Like I mentioned before, /31. But I said it breaks the rules of subtracting 2. Why does it break the rules? Because if I took a /31 and we had 1 host bit left over, that would be 2 to the power of 1 minus 2 equals 2 minus 2, which equals 0. No values left over because we're subtracting 2, right? But what it says is you don't have to subtract 2. RFC 3021 says you don't have to subtract 2, which means you assign the network address to one interface and you assign the directed broadcast address to the other interface. That's the only exception to that rule. Now, for the certification exam, I don't, at this point in time, need you to worry about /31. /30, absolutely. So what type of address are you going to pick? If you have 2 devices you're connecting to back, you only need 2 addresses then, /30 is the way to go. All right, but I want to notify you that there is a /31 option nowadays. If the device supports it, they've been configured to support RFC 3021 by the manufacturer of that product, then absolutely you could go with the /31 if you want to, and then you're not minusing 2 anymore, and you're using every single one of those addresses instead. But definitely /30, pretty common option for people to use still now to this day. So in this case, we would have had, let's say this is the 10 address, 10.9.0.13 being assigned here, 10.9.0.14 being assigned here. And so the network these belong to would be 10.9.0.12/30. And your addresses would be .12, .13, .14, and your directed broadcast address would be .15. So that'd be your directed broadcast address. There's your network ID. There's your first usable. There's your last usable. If you're like, whoa, how'd you do that? I'm going to show you how to do that. I'm definitely going to show you how to do that. Now, let's say we had a connection like this, where you had your headquarters router and your headquarters router connected up to a bunch of different branch offices. Right? And they're all in the same subnet here. So if we look at the the IP addressing, you'll see 10.9.65.17 on this one. This one has .18. This one has .19. This one has .20. This one has .21 assigned to it on the interfaces, right, connecting to each other. So we're all in the same subnet right here, even though we're geographically separated apart. But in this particular case, our network ID would be 10.9.65.16/29. So our first usable would be 17, then we'd have 18, we'd have 19, we'd have 20, we'd have 21, we have 22, we'd have 23, oops, not 32, 23. And so this would be our directed broadcast address. This is our first usable, this is our last usable, and this is our network ID. So in total, in a /29, we have how many different addresses that we can use? We got 1, 2, 3, 4, 5, 6 that we can use in a /29. Well, let's go back and just check to make sure that that is accurate. If we look at this chart here, there's a /29. We see that we have 6 that are usable, 8 in total, but only 6 that are usable. And that's what they would be in this particular case. Again, if you're like, whoa, how'd you do that? I got you covered. We're going to get to that momentarily. But let's now talk about, like, for example, this is our distribution layer in our organization. This is the core in our organization. Remember, this is the access layer in our organization. So what we have in this particular case are point-to-point links here, point-to-point links here. So on a point-to-point link, right, this is where we're doing routing, and you're like, wait, no, Raymond, we have VLANs there. No, right? VLANs are here. VLANs are here. Subnets are here, right? VLANs are here. Trunks are here. I mean trunks, not subnet. Trunks, right? What else do we got? We got spanning tree protocol here. This is layer 2, right? Okay, this is layer 3. Layer 3 means routing. That's what it means. So we need networks here. We need networks here. We need networks. Well, since there are only 2 devices, one layer 3 interface here, one layer 3 interface here, what does that mean? It means /30 network. That's what that would mean. /30 network. So /30 networks all around. So you can see /30, /30, /30, /30 in this case. So in this example here, what do we got? This is core switch 1. So let's say this is core switch 1. This is distribution 1. Let's say this is distribution 2. So core switch 1 using .1 here, and distribution 1 using .2 here. Core switch 1 using .5 here, and then core switch distribution switch 2, using .6 here. So when we think about this network here, that would be 10.9.240.0/30 with an addresses of 1 and 2 and a directed broadcast address. And then this network right here would be 10.9.240. It'd be 4/30 with addresses 5 and 6 and a directed broadcast address of .7. So network ID, first usable, last usable, directed broadcast address. So 4, 5, 6, 7 for that one, 0, 1, 2, 3 for that one. Now let's think about our subnet /VLANs /broadcast domains we have. So think about this part of the network. Maybe you have VLAN 10 deployed here, you have VLAN 20 here, and you have VLAN 47 here. Right? Why did I use 47? Because if you look up here, 47 is what we have in the example. That's the only reason why I grabbed 47. All right. So with this in mind here, right, this is our layer 2 environment down here, right? All of this down here is layer 2, right? And then up here, we've got layer 3. So what we need is we need default gateways, right? We need default gateways up here for our environment. These are multi-layer switches, not routers. It'd be no different, for example, if I had a router connected up to a switch, right? And we had all these down here. And then we need what? We need an IP address on that router as the default gateway. Well, you need that also with your multi-layer switches. That's what you need right here, because they're going to act as a default gateway for those subnets, for those VLANs, for those broadcast domains. The thing is, you can't configure it on the actual port, because if I configured it on the actual port on this, then what happens? Well, that would only be associated with one of those VLANs in this case. You can't do sub interfaces on multi-layer switches. So instead what we have is we have these virtual interfaces called SVIs. That's what they're called, switch virtual interfaces. So interface VLAN 47 in this case is an interface, a layer 3 interface that can be utilized to route traffic in and out of the subnet associated with VLAN 47. That's what that means. Let me repeat that for you. An SVI is a layer 3 interface on a device that can route traffic for the subnet, in and out of that subnet, associated with VLAN 47. So I would also need an SVI, in this case, for VLAN 10. I would need an SVI for VLAN 20 configured on those devices, my multi-layer switches. And so that is your default gateway. For example, right now, we'll talk about first hop redundancy protocols later, which takes that concept a little further. But for right now, think about the SVI as the default gateway. It would be like your router interface that you'd have that's connected to your switch, right? But in this case, it's not a physical interface, it's a virtual interface, because when you think about your multi-layer switch, right now we only have one link coming in, but your multi-layer switch has like potentially hundreds and hundreds of ports. And if all those ports are part of VLAN 10, 20, and 47, I can't use a physical interface then for all of those, right? I need to use what? I need to use a logical virtual interface for all of those interfaces that are part of VLAN 10, 20, and 47 on the device. So now, because I have an SVI, it can route traffic on any trunk port or any access port that is part of VLAN 10, 20, or 47, as long as I have an SVI for it. So in this case, VLAN 47 interface, I should say VLAN 47, is specifically for VLAN 47's subnet. And so I give it an IP address in this case. So let's say this is DSW1 right here, and this one's DSW2. So you'll see that I give it the IP address 10.9.4.1/24, and I gave 10.9.4.2/24 to my other router, or my other multi-layer switch for interface VLAN 47. So now I got redundant default gateway now for VLAN 47. So I do the same thing for VLAN 10. I do the same thing for VLAN 20, and I'd use different IP addressing, obviously, different subnet, different VLAN, different broadcast domain. But again, when you're using SVIs on your multi-layer switches, typically you're going to use a /24 network for that. What about our wireless LANs? Well, wireless LANs are going to vary depending on what your plan is for your wireless LAN. You can have a lot of devices, a little bit of devices. It varies depending on your scenario and situation. You could have a /23, 24, 25, 26, right? It really depends on the size of the wireless LAN and how many devices you expect connected to that wireless LAN. Okay? All right. So I want to give you a visual representation of a /24 network right now. Going to get out of the way. Here you go. Boom. There it is. Right. So what particular network is this? This is the 10.9.0.0/24 network. There's your network ID. There's your directed broadcast address. There's all of your usable addresses, every single one. There's 254 usable addresses in there. All of them are listed right now. If we go back to the slide, what did we say for a /24? We said a /24, very commonly used for subnets, VLANs, broadcast domains. For our end users, 254 total addresses. There they are, as one example. Notice you're starting, right? We got 0. We're ending at 255. That is true for all /24 networks. Starting at 0, ending at 255 in your 4th octet. Starting at 0, ending at 255. Keep that in mind with a /24. Good things to memorize. /24 starts at 0, ends at 255. Take a look at this. You can see that. Network ID. First usable address is 1 more than it. There's your directed broadcast address. And there is 1 less than the directed broadcast address is your last usable address. So these are all the usable addresses. There's 254 of them here. And just to give you another visual representation of that, there they all are. Every single one of them. Now, another thing I want to point out to you as we're standing here is take a look at the 2nd octet. Sorry, the 3rd octet. Can anybody tell me what we're progressing by in the 3rd octet? What number are we progressing by in the 3rd octet? If I'm going from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9 to 10 to 11 to 12, we're progressing by. So whenever you have a /24, you're progressing by 1 in the 3rd octet, which means you automatically know that if you have /24 networks, you would have something like this. And then you would have something like this. And then you would have something like this. And then you had something like this. And then these were all your network IDs, right? We don't have to overcomplicate subnetting. We can keep it simple by just recognizing these patterns. Every /24, we're increasing by 1 in the 3rd octet, right? So you might be saying, oh, what if we had like 10.255.0.0/24? Okay, well, let's just keep counting. 10.255.1.0, 2.0, 3.0, 4.0, 5.0, same thing, just progressing by 1. Oh, but Raymond, what if it's like 192.168. Let's say 59.0/24? Okay, well, we're still progressing by 1, right? So 58, 57, 56, 55, 54, 60, 61, 62, 63, 64. Keep it simple. /24 is progressing by 1s. Those are all your network IDs. Those are all your possible network IDs. That's what I'm writing out for you. And you can easily figure that out too. Just remember, /24, the 3rd octet's always going to count by 1, up or down, depending on what we're trying to figure out. Right? Little shortcuts here. I'm trying to help you out with the exam so you can position yourself rightly on a question on the certification exam. So we know /24 now, progressing by 1 in the 3rd octet. We're going to always have a network ID that has 0 here. We're always going to have a directed broadcast address that has 255. And we typically deploy these for what? Our end user subnets, our end user VLANs, our end user broadcast domains. All right, good information. Okay, but now let's say I want to do some subnetting, right? We don't actually want to use /24s. Or we have /24s that we're going to use, but then I want to do some subnetting with some of the other ones. Okay, so right now, let's say we have this network here, and we don't actually deploy it. Okay, we don't actually deploy it. Right? Can I subnet it? Can I break it up? Absolutely. Absolutely. Right? So what does subnetting do? Think of it this way. You have a pizza. If I cut a pizza, what have I done? I've divided it, right? I've divided it. So think of it this way. When I subnet, I'm dividing up that addressing space. So right now, this addressing space looks like what? This addressing space looks like this. That's what it looks like, right? So what if instead I wanted to divide it up? Well, let's just carve it up right here. Let's cut it right here. Okay, how do you do that though? How do you actually do that? You do that by changing the subnet mask. What if we change the subnet mask from a /24 to a /25? Let's do that right now. Change it from a 24 to a 25 instead. What's going to happen? There you go. Pizza. Cut. What do you have? Two halves. Take your /24, cut it in half. You have two halves, and there's your new subnet mask. That's subnetting. What did we really do? Okay, from a binary standpoint, which I really don't want you to worry about for the exam, right? Because you don't want to get lost in binary. But if you come back to this page right here, right, all we did was what? Take a peek. This is what we had before, right? What did we do? We turned it into a 1. We turned the 0 into a 1. That's all we did. We borrowed 1 bit. Actually, we stole 1 bit from the host portion. We're not giving it back. We borrowed 1 bit from the host portion. What does that do for us? Boom, splits it in 2. Just like that. We borrowed 1 bit, splits it in 2. Just like that. It's beautiful. Okay. So now look at your network ID. You still have this network ID, but instead of it being /24, what is it now? It's /25. Right? The subnet mask changes that. Look at the directed broadcast address now. It's 10.9.0.127. Right? Look at this next network ID, /25. Look at this other directed broadcast address now. It's 255. We've cut it. We've split it up. So if we go back to that other page, and we look at this again, and we'll clean this up. One network supporting 254 devices, right? But instead, I want 2 networks, each supporting 126 devices. So we can cut this in half, and that's what we'll get. So now, let's say we look at our network this way. There's that network, 10.9.0.128/25. Where is that? That's this one right here. Right up there. The purple one we just created. So we can deploy it over here now. Look, the network ID is 128. The directed broadcast, as we saw, ends in 255. But then our first usable is 1 more. And our last usable is 1 less than the 255 in this case. But that's for this one. Okay? But what about this one? This one is 10.9.0.0/25 is the network ID. The directed broadcast address would be what? 1 less. 1 less than this one. Okay? So when you're thinking about that math now, think about rolling back the odometer on your car. If you had a car, let's say with 10,000 miles, and you rolled it back, this is 0.9999, right? You're rolling it back. Well, the same thing has to happen here. So if I roll this one back, it's now 10.9. What? 0.127. So 10.9.0.127. Then go back 1 from there. 126 is your last usable. Go 1 up. There's your first usable address. Okay. So now what do we have? We have 2 different networks now, right? I have 2 different networks. I got this one that starts here. I've got this one now that starts there. So 2 different networks. So the question is, so does it start with .128 or does it either one or the other? I have 2 networks now. I got one that starts with this, 10.9.0.0, and I got one that starts with this. I got 2 networks now, not one. I got 2. That's what subnetting does for me. Whereas in this case, if we did /24s in our organization, then you got 1. In this case, 1/24 gives me this. But if we subnet, break it up, then you've got 2. Yeah. Okay. Now you got 2. So how many devices can we deploy here? Well, I can deploy 126 devices in this network, and I can deploy 126 devices in this network. So a while ago, let's do it this way. Let me draw a picture here now. So a while ago, my example was with a /24, right? So a /24, you got your switch. That means here, I can deploy 254 devices, right? And the network was what? The network was 10.9.0.0/24, okay? But now, what do we do if we subnet like this? Well, now, instead, I've got this network I can deploy, which gives me 126 devices. And I got this network over here now I can deploy. Right, another network, and this is going to be 10.9. 10.9. You can see that 10.9.0.128/25. Does that help you see that better now? So a while ago, it was only one network off of one router interface. Now I can have 2 different networks off of 2 different router interfaces, each supporting 126 devices instead. Right, that's what subnetting does for us. Now, I mean, could I have like a /24 network here? Let's say this is 10.8.0.0/24, right? Supporting 256 devices, and another /24 network here. And let's say this is 10.10.0.0/24, sure. Right? But I'm just trying to show you, like, there's my subnetting. Right? I've taken a /24 network, cut it in half. I can have 2 different networks now instead of 1. Obviously, you can see the networks are getting smaller and smaller and smaller. So what does that mean? It means you're going to deploy some 24s in your network. You might deploy some 25s in your network. You might deploy some 26s in your network. It's up to you how you want to subnet and organize your organization. But that's the concept of subnetting is what we're doing here. Right? So when you look at this page again, you come back to this one, right? If we subnet a bunch of 24s, then this is what you're getting if you subnet them once. Right? Now you got 10.9.0.0.20. This one would have been turned into these. Right? If I had 10.9.1.0/24 and I subnetted it, cut it in half, then we'd end up with these 2 here. If I had 10.9.2.0/24 and I subnetted it, cut it in half, then we'd end up with these 2 networks right here instead. So instead of having 1 network, we now have 2 networks. Right? Obviously, they support less devices, but that's the concept of subnetting. Right? Okay, let's take this further, right? So if we take a step back here, let's remind ourselves, there's 24. Right? Let's cut it in half, subnet it into 2 different networks instead of 1. That's a 25. So you got your 2 different networks now. Okay? Let's cut it again. Right? Think about your pizza right now for just a moment. If I have a pizza and there's my /24. We cut it. Now we got 2 /25s, right? What if we did this? Now we've got a /26, a /26, a /26, and a /26. So how many do we have? We now have 4, don't we? Yeah, look at that. Boom, there's the 4 of them. So now you got a network that starts at 10.9.0/26 and ends at what? 10.9.0.63. This one starts at 64 and goes to 27. This one starts at 128 and goes to 191. This one goes from 191 to 255. Think about the pattern you got here. If you think about this network here, right? Go back to the /24. When you think about the number of addresses you have in total in total you have? How many do you have in total per subnet? Well, go back to this page. It'll tell us. We have 0 to 255. That's a total of what? 256. So what does that mean? Right? Every single one of these subnets have 256 possible addresses. Right? If we cut it in half, each one of these had what? 128. 128. If you go from 128 to 255, that's 128. 0 to 127, that's 128. We cut it again. What do you have now? Each of these have 64. These sound like powers of 2. Yeah, they are, right? 256, 128, 64. Yeah, because binary determines our dividing lines, and that's what we have here. That's what's going on right now. So, so if you had a /24, 10.9.0.0, and you subnetted it down to a /26, well, it says here we have 4 different subnets, and each subnet now has a possibility of 64 addresses. Can't use 2 of them, so the answer is 62, 2 to the power of h minus 2. What about if we went to /27? There you go. Now it's 32s only in each, minus 2, which is 30. What if we went to /28? Now you go, how many subnets? 1, 2, 3, 4, 5, 6, 7, 8. Total of 16 subnets in this example. And each of them has what? 14 usable addresses in each. 16 total addresses, including the network ID and the direct to broadcast address. So we're going by 16s now. All right, let's go to 29. Now it's 8. But look at more subnets. Less addresses per subnet, obviously, but okay. So think about the sequence we have going on here. Right, if we take a step back, with a /24, what do we say we were progressing by? Okay, well, if we go to this page here, we said in the 3rd octet, we're progressing by what? We're progressing by 1, 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 right? That's what we're saying. Okay, well, when you're a /25, what are you progressing by? Well, now you're in the 4th octet. 4th octet, not the 3rd. You're in the 4th once you get to a /25. And you might be saying, well, why? Well, let's just take a step back. If you go back to this chart, we're in the 4th octet with a 25 because look, this one is in the 4th octet here, right? With a /25. So the reason why we're in the 3rd with this one is because our last one is in the 3rd. It's right here. We're in the 4th octet with a /25. That's why I'm now using the word in the 4th. So we go back to here now, right? What are we counting by? What are we progressing by if we are a /25? We're counting by or progressing by the number 128. Counting by 128, 0 to 27 to 128 to 255, 128. Right, and we can kind of see that progression here as well. If you look at this, 0, 128, 0, 128, 0, 128. You see that? Right. When we get to a /26, what are you progressing by? You're progressing by 64 now. So when you're counting, right, and you're in the 4th again, you're in the 4th, but you think about it, 0, 64, 128, 192. You have the ability to figure out all your network IDs for that subnet mask if you understand this counting concept. Right, let's take it to a /27. What are you counting by? We said 32. If you're counting by 32, you know it's 0, 32, 64, 96, 128, 160, 192, 224. You see that progression? You can figure out the network IDs without even needing to do any binary. You know your subnets. You can figure them out if you know this counting progression. Right? Look at /28. Now it's 16, we said. 0, 16, 32, 48, 64, 80, 96, 120. We're just counting by 16. That's all we're doing. Counting by 16. And we can figure out every single network ID. Right? What about /29? Well, now it's 8. 0, 8, 16, 24, 32, 40, 48, 56, etc., 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 etc. Why does this matter? This matters because if I gave you something like this right now, and I said, hey, would this configuration work? Why or why not? Right? You need to look at this and ask yourself, what is going on? Well, think about it. This is a point-to-point link. We really only need 2 addresses, right? One address here, one address here. Well, there's an address, there's an address, right? They're not using a /30 mask. That doesn't matter. That doesn't matter. That's not the problem, right? The question is what is the requirement? The requirement is that both of these interfaces must be in the same subnet. And neither of them can be the network ID or the directed broadcast address, right? They must be in the same subnet, and neither of them can be the network ID or the directed broadcast address. So, knowing that a 248 is what? We said counting by 8. You know that the first network ID would be 10.9.0.0 slash, and a 28, or sorry, 255.255.255.248 would be what? It would be a /29. So if we're counting by 8 in the what? In the fourth, right? In the fourth, 0, 8, 16, 24, you can now start counting if you want to. You can say, well, the next one is 8. The next one's 16. The next one's 24. What's the next one after 24? 32. And you keep going, right? You keep going. So I'm going to keep going here. What do we got? 40. And then we've got 48. And then we'd have 56. And then we'd have 64. And so I can stop there because I want to compare this number and this number now. This, remember, these are network IDs, network IDs, network IDs, network IDs. That's what you're doing, right? You're counting the network IDs. That's all you're doing. You're progressing by 8 for network IDs when you are /29. So we now know that 57 has a network ID of 56. So the network ID would be 10.9.0.56/29. That's the network ID that IP address lives within. Okay? That's what I'm figuring out here. And so that's the network ID. So that means if we keep going with this, the first usable would be 57. The directed broadcast address would be what? Well, the directed broadcast address is 1 less than the next network ID. The next network ID is a 64, right? So the directed broadcast address would be a 63. And if we take 1 less off of that, that would be what? 62 would be the last usable address. So I just figured out that for that addressing space right here, 10.9.0.57, we've got a network ID of 56. First usable is 57. Last usable is 62. Directed broadcast address is 63. So is this address and this address, are they in the same subnet? Yes or no? Are they in the same subnet? Answer that question. Yes or no? Based on what I just did, are they in the same subnet? The answer to that is yes, right? Because the subnet goes from 56 down to 63, correct? You see that? They're in the same subnet. But the next question is, are they valid addresses? Is this a valid address? Is this a valid address? Right? The answer to that is, this is valid. This, not valid. Why? That's the directed broadcast address, right? So this would not work. So the question is would this configuration work? Why or why not? The answer is this configuration does not work. Oh, what did I do? Oh, I just switched pages. this configuration would not work because that address, this one right here, is the directed broadcast address for the subnet. That's why it wouldn't work. Now, I showed you earlier today that you can't actually do that, remember? If you tried to do that on a router, the router would yell at you and say, you can't do that. But that doesn't stop an exam developer like CompTIA, Cisco, anybody like that, from actually showing you this and going, oh, what's the problem? Well, that's the directed broadcast address. Even though I can't do it in the real world, they could still put it on an exam because they could type anything they want in an exam, copy and paste, and create any pictures they want and say, why doesn't this work? Because that's the directed broadcast address. So remember, you can't assign, you wouldn't be able to assign 56. If it was 56 that was on the interface, let's say up here 56, okay, that's wrong. That would be the network ID. The network ID cannot be assigned to an interface or the directed broadcast address. Right, so let's take a look at now this chart, because this chart shows you exactly what I just did, but it's already done for you, and you don't have charts on the exam, right? So if you don't have charts on the exam, how are you going to figure this out? Well, let's take a look here. Subnet number 56. There it is, right down here. There's 56. You see that network ID is 56? Hey, look at that, we got it right. 57 to 62, 57 to 62, and then the directed broadcast address is 63. So this is the type of math that if you can do on the exam becomes super easy with this stuff. And by the way, what I'm showing you today is going to really, really be needed if you are taking like Cisco CCNA down the road. Right, let's take a look at this example now. So the same question, but they're asking you, hey, what's wrong? Is this going to work or not? And remember, if we're looking at a link like this, we know they need to be in the same subnet, same VLAN, same broadcast domain. Even if you had a more complicated diagram, let's say you had like a switch here and you had PCs here and they were asking you about this. And they showed you a configuration of a PC, they showed you the configuration of a router, they showed the configuration of another PC, and they say, what is wrong? Well, you got to figure out from an IP addressing standpoint, what are the valid addresses in that subnet? And then just compare it to all the devices and say, are those the right IP addresses, and are they the right subnet masks to accomplish the objective? That's all you're trying to figure out. So in this case, got to do the same thing, right? Slash dot 248. If we remember, 248, we're counting by 8, we said. So if it's 248, we're counting by 8. So let's go ahead and count by 8. We'd have 10.9.0.0, and then you'd have 8, 16, 32, 24, 32, 40, 48, and then we have 56, and then we have 64, and then our next one would be 72. So 57 lives here, right? Between here and here, and 65 lives between here and here. So already we know what? We know this will not work. Why? Because this and this have to be in the same subnet. Are they in the same subnet? No. This one is in this subnet. This one is in this subnet. So let's go over here and take a peek at the math that we're showing you, right? Where is 57? 57 is in this subnet, and 65 is in this subnet. There you go. So if you can remember what you're counting by for all of these, that's really, really important. So when we went back and we took a look at this, right? We said we're counting by 128 if it's a size 25. If it's a slash 26, we're counting by what? We're counting by 64. And then if it's a 27, we're counting by what? We're counting by 32. If it's a 28, we're counting by 16. If it's a 29, we're counting by 8. Right? And that's where we are right now on the 29. Right? One more. Right? If we look at this example here, same thing. We're still counting by 8 in this example, but we're trying to wrap up this example. And in the end, right, if we go back to our counting, we said 10.9.0.0, and we were counting by 8. So we got 8, 16, 24, 32, 40, 48. And then after 48, we're going to have 56. And then we're going to have 64. We're going to have 72. Let's stop right there. 58, right, lives between 56 and 64. 61 lives between 56 and 64. And so we know it's going to be 56, 57, and then 64 is the next network ID. So you back off by 163, back off by 162. So now you have your directed broadcast address, you have your last, you have your first, and you have your what? You have your network ID. So 58 is valid. It's a valid address in here. 61 is a valid address in there. They're both valid. They're both usable. And if we look over here at 56, network ID, 58 is there, and so is 61. So I'm showing you how to basically build this chart on the fly, folks. When you think about all these numbers here, those are all the blue numbers there. You see that? Those are all the blue numbers. And you're just trying to figure out the blue numbers to get you to the point where you can compare those addresses to where they need to be. And then you can figure out, well, are they in the same? Are they? Yes, they are in this case. That's perfect. Whereas in this example, right, they weren't in the same subnet. They were in two different subnets. And you could figure that out just by figuring, oh, 57 lives here, 65 lives here. And then in this example, even though they were in the same subnet, right, the problem was that was the directed broadcast address. So by doing this, we can figure out network ID, first, last directed broadcast address. No binary involved. No binary involved. So by knowing your progressions, you're able to figure that out. Okay, what about /30 now? Let's go to /30 because we just did 2930. Remember we said we're counting by 4, right, for that one. Why? Because we have 4 addresses, 4 total addresses per subnet. That's what we have. 4 total addresses per subnet. So you can see that you've got 4, and you got another 4, you got another 4. So what are you doing? You're counting by 4. Look, 0, 4, 8, 12, 16, 20. And then you can't use the network ID. You can't use the directed broadcast address, leaving you with the 2 addresses you need for what? Your point-to-point links when it's all said and done. So /30, counting by 4. All right, and so now, if you just take a look at this example here, let's pick this one out right there. Network ID 12. Directed broadcast address 15. First usable 1 more. Last usable 1 less. So there you go, 12, 13, 14, 15. Have you noticed how all your network IDs, when you are /25, 26, 27, 28, 29, 30, right? The network IDs are always even numbers. Did you notice that? They're always even numbers. They're not going to be odd numbers. The only time you have odd numbers is when you're like a /24. Because then you're going to have 0, 1, 2, 3, 4, 5, 6 as your network IDs in the what? The 3rd octet. Not the 4th, but 3rd in that case. Right. So far, what have I taught you in this particular case? I've taught you to make sure that you absolutely are familiar with what? You're counting so far for all of these. Right? What did I explain to you? You know, counting by 1 in the 3rd for a /24. So that way there you are 10.0.0.0. Then you're like 1.0, 2.0, 3.0, 4.0, right? In the 3rd. Right? But now if we're doing like /25, then you'd be counting by 128 in the 4th. So 10.0.0.128 in the 4th. Then your next one would be 10.0.1.0 and then 1.128 because we're counting by 28s, 28s, 28s as we go up in our network IDs. Right? And then if you're a /26 and you were 10.0.0.0/26, well, then you're counting by what? 64. So your next network ID is 64. Your next one's 128. Your next network ID would be what? 192/26. So there's your network IDs as an example. Right? Take it a step further and let's go with like 27. The /27, what are you counting by? You're counting by 32. So then you got 32 as the next network ID. And then after that, you got 64. Then you got 96, and then you got 128, and then you got 150, and then you got 192, and then you got 224, and then it's 1, 2, 3, 4, 5, 6, 7. That's all of them. Okay, in that case. So as you can see, if you know how to do that and you have these memorized, then you can figure out all the network IDs. And if you can figure out all the network IDs, then you can figure out all the addresses in between. And if you can figure out all the addresses in the between, then you can answer any question that shows up on the certification exam. All right. But now what I want to do is I want to talk a little bit about like 23s and 22s because this can get confusing, right? One of the best ways to look at a /23 is that really you've combined together 2 /24s. That's really what you've done, right? Because we typically deploy /24s, and a /24 gives you like 254 devices in that subnet VLAN broadcast domain. But what if you need more than that? Well, then, you know, combine 2 /24s together, you get a /23. So instead of subnetting, we're combining them together, right? And in the end, what do you get? You get a subnet mask of /23, 255, 255, 254, but you've combined 2 networks together, essentially, okay? And you don't have to think of it that way, right? And I don't really think of it that way in the real world, but it helps people understand it a little better. that when you look at what's going on here, if I had, for example, like 10.9.128.0 and 10.9.129.0/24, right? These are two /24 networks, right? What is a /23 essentially? A /23 would be you taking both of these and making them into one. That's essentially what you'd be doing. So, and what would the answer be to that? The answer is that. There it is. 10.9.128.0/23. And you can see here that when you're a /23, you are progressing by 2 in the third. So if you're a /24, you're progressing by 1. If you're a /23, you're progressing by 2. So 128, then 130, then 132, 120, and so on and so forth. So for example, let's just go back to like just showing you, like if you had 10.0.0.0/23, what would the next network ID be? Well, if you're progressing by 2 in the third, the next one would be 10.0.2.0. The next one would be 10.0.4.0. The next one would be 10.0.6.0. That's how you'd be progressing in that particular case. So by understanding what you're progressing by in your subnets, it allows you to figure out what's going on. So when you think about this subnet now, that's every address from 10.0.0.0 all the way to what? Well, if the next network ID is 10.0.2.0, roll that back. If you roll it back, you got 10.0.1.2 becomes 1, and then roll this back, and you got 255. So your first address is 10.0.0.1, and then your last usable address would be 10.0.1.254. So notice, like, right, we have a lot of addresses here. We got more than 254. We actually got 510. So from here to here is 510 addresses, because it's everything from 10.0.0.0 to all the way to 10.0.1.254, right? So you see how this helps you just figure out what are the addresses that are usable in that range, right? /22, right? Now, look at this. We're progressing by 4 instead. 4. So 60, 64, 68, 72. So again, if we had 10.0.0.0/22, what's the next subnet that would be a /22? It would be 4.0, and then 8.0, and then 16.0, and then, nope, that's not counting by 4, 12.0, then 16.0, counting by 4. Right? So now you know, like, for example, if this is the network ID, then the first usable would be .4.1. The directed broadcast address would be .7, right? Roll back the 8, roll back the 0. So then the last usable would be .7.254. So every address from 10.0.4.1 all the way up to 10.0.7.254 would be in this network right here of 10.0.4.0/22, includes all of these usable addresses with a directed broadcast address of 255. Woohoo! I love it. This is finally making sense. I love it. When I see that in the chat, it means what I'm doing is right, and it's coming across correctly. Yes, replay this video 100 times. I'm serious, okay? Now, I'm going to give you a different representation of this exact thing I just talked to you about, the 23s, 22s. Look at this, okay? So think about this. If you had this one network, there's your /24 network, right? Well, if you combine 2 of them together, right, there's your /23. There it is, right there. You see that? 23. Right? Combine these 2 together. 2, right? When you combine 2 together, you get a 23. Combine 2 together, you get a 23. Notice it's 0, 2, 4, 8, 6, 8, counting by 2s, right? By 2. So this is by 1. This is by 2. Guess what? This is by 4. Right? So if we combine 4 together, or these 2 together, you see how you get a 22? You're counting by 4. You're counting by 0, 4, 8, 12, counting by 4. Right, let's take it further. We'll even go further now. Let's go to 21 just to show you. If you combine together 8 of them, there's 8 of them. 8, which would be combining like 4 of these together, or combining 2 of these together. Right, now you're counting by what? You're counting by 8. Right, 0, 8. Why? Because you combine 8. See, 8 24s, you're counting by 8. Right, counting by 8. There's 8 of them there. right? Let's take it one step further just to make this click even more. Look at this, by 16, right? Why? All 16 of them. So the next one would be 10.9.16.0/20. That would be the next network because you're counting by 16. Just like the next one down here would be 10.9.16.0/23. Right? If we're counting by 4, the next one would be 10.9. It's still 16.0/22. This one would be still 10.9.16.0. But look, the subnet mask changes. So even though a lot of these network IDs are the same, right, the subnet mask is changing what's actually happening and how many usable addresses are in each. Come on, camera. Refocus on me. There you go. All right. So the key here for the certification exam is to make sure you memorize this. If you memorize this, it becomes really easy for you. If you don't, it becomes hard, right? If you can remind yourself that, hey, if I'm a /22 network and they're giving me a /22 network, then I'm counting by 4 in the third octet, then I can really figure out what all the network IDs are, given an address, any address, right? What if they turned around and they did this to you? Right? This is where the fun stuff begins, right? I'm just going to pick a random address out of my head. I got no notes here, no nothing. I'm just going to grab an address. So let's say we had the address 10.67.54.32/22 thrown at us on the certification exam. All right? It's like, all right, you want to figure out, like, and they have other questions like, it's about addressing. Is this right? Is this wrong? Does this make sense? All of this stuff. Well, what do you easily do? Okay, we got 22. 22 says 4 in the third. 4 in the third. So what do you got? You count by 4 in the third. So your first subnet is 67.0.0. So notice what I did. I zeroed out the third and the fourth. So if you're counting in the third, you zero out the third and the fourth. If you're counting in the fourth, you just zero out the fourth. That's your starting address. This would be the very first network ID. That's how you figure out, right? For your counting, for your progression. There's your first one, right? In the third, okay, 0, 0. And now we got to count by 4. All right, so now we got to go like 4, 8, 12. Okay, that can take a long time, right? It can take a long time. But what I want you to realize is that you're eventually going to hit powers of 2. I guarantee you that. So you know that if this number is the one you're looking for in this calculation right now, 54, right? If you're going to hit a power of 2, what are your powers of 2? You got 128, you got 64, you got 32, you got 16, you got 8, you got 4, you got 2, you got 1. Okay, we're eventually going to hit 32 no matter what. So I'm just going to go 0, skip a few, 32. Because I know I'm going to hit 32. Why count all the way to 32 when I know I'm going to hit 32? I also know I'm going to hit 64, right? Because 64 is another power of 2. So now it's just about counting 4 here. So I can go backwards by 4 if I want to. If you like going backwards, you can totally do that. Right? So what would the next network ID be if we were going backwards versus forward, if we're counting by 4? Right? Would it be 60? It would be, wouldn't it? Right? And we can keep going backwards if we want to, or forward if we want to. So let me just go ahead, and I'm going to go forward just to keep it simple for myself. So we got 36. We then got 40. We then got 44. We then got 48. We then got 52. We then got 56. Okay, I can stop. See 54? Right there. Boom. So now we know the network ID is going to be 10.67.52.0/22. We know the next network ID is 56. So if the next network ID is 10.67.56.0/22, okay? Now we know that network ID. So we can figure out the range in here. So now the first usable address is 10.67.52.1. And the directed broadcast address is going to be one less. So 10.67, roll back 56, that becomes 55. Roll back 0, that becomes 255. And then your last usable is 10.67.55.254. So this address right here, this whole address lives in this network with all of these other addresses. And there's a directed broadcast address, right? But it all starts with you knowing this. If you don't know this, you can't figure out the network IDs. And so that's a good skill to have for the certification exam.